Hello. This video outlines the steps to program a solid for the MoriSeiki NZ machine using the Esprit software that's included in your MAX4 control. The machine we like to highlight today is the MoriSeiki NZ T3Y3 machine, which consists of two spindles, three turrets, two upper turrets, and one lower turret. The lower turret can be shared by both the main spindle and the sub-spindle, and all three turrets are equipped with Y-axis capabilities. So let's go ahead and see the steps that what we're going to need to program this solid, or any solid inside the SoundV4 software, in a simple three-step process. The first step is going to be to define the features that we want to machine. Second step would be then to apply the appropriate machining technology on those features. And then the last step would be to optimize or synchronize the machining operation. So taking a look inside the Esprit software, we can actually see here's our solid part. And so the first step is to define the features to be machined. We do that very simply and easily with the automatic feature recognition. Select the button, select our solid, and as you can see here, our features are automatically created. Our features are created for our front face, back face, OD, ID, and even we provide a distinct feature for any grooving cycles that need to be created. Also, I want you to take a closer look here. As you can see, the features are organized by side, with the left side of the part being created for the main spindle and the right side of the part being created for the sub-spindle. So now we have our features created, and then the next step would then be to apply the appropriate machine technology. So the first technology we may want to put on our part would be a balanced roughing operation. Balanced roughing operation performs a roughing operation about twice the speed as fast as a normal roughing operation by using two tools mounted on separate turrets. So the two tools can cut simultaneously, or one tool can lead and the other tool can trail or lag behind by a specific distance. And all these can be programmed very simply and very easily within the Esprit software. So we go ahead and we'll open up our technology page here, and you can see here the first thing we're going to do is define the spindle that we want to use, and then go ahead and select the tools that we want to use to machine this specific feature. Also then we're going to go ahead and define our feeds and speeds that we want to use, and then how we want to go ahead and rough that out. Fill that information out, and then we have the option if we want to go ahead and place the finishing operation on there. Go ahead and click OK, and then you can see we have our toolpath on there. Secondly, maybe we want to go ahead and put a grooving operation on here. So let's go ahead and do that. And again, we select the feature, we open up our grooving page. But what I want to show you here is that the pages are very similar. So again, our strategy, spindle tooling we want to use, feeds and speeds, and in this case here, what kind of information we want to fill out, how we want to actually groove that specific area of the part. Fill that out, click the OK button, and again, we have our toolpath on there. And then we do that for each of the appropriate technology on there. We will go ahead, select the proper feature, put the technology on there. Very simple, very easily. So again, here I want to show you. You can see here, this is where I left you off, and then I went ahead and programmed the rest of the part. Exact same way, very simple, very easily. Now, what I want you to pay attention to here is that now that everything has been programmed here, you can see specifically that the balanced roughing operation, I placed the balanced roughing operation on the upper left turret and also one on the upper right turret. And as it stands, both of them are going to occur simultaneously. We don't want that happening. We want to go ahead and optimize our machining cycles and make sure that specific turrets will start and wait before other ones begin. And we do that by adding sync codes, and we do that very simply and very easily in Esprit. And here I'm going to go ahead and show you how we do that. So we go ahead and select the operation from the lower turret here in this case, and then the upper right turret, and then I'm going to go ahead and click my sync button, and I've got my sync codes, and my sync codes can be placed above that operation or below that operation. The other way that I can do this, because Esprit is Windows based, is I can drag and drop, and you can see I'm doing that right now. I'm dragging one operation on one turret to the other, and then I'm adding my sync codes that way. And so now here, what I've done here is I've optimized my machining cycles here to ensure that I want to be able to balance what's being done on the upper turret and the lower turret to optimize and reduce my cycle times. Now, the next step here, what I'm showing you, is the comprehensive simulation and complete collision detection. And actually, we're showing you the machine setup. We're showing you how this will run on the MoriSeiki NZT3Y3 machine. So the actual kinematics of the machine are actually happening inside the S3CAM software. And so that will give you a realistic verification how that part is going to be machined, eliminating any problems it may have. So if I see it within the software, I can very simply and easily stop it, correct it, then we go ahead and re-simulate that to make sure that it's perfect before I send it out to the machine tool. So comprehensive simulation and collision detection gives you the confident and immediate feedback that you need, along with being able to program any part very simply, very easily within the S3CAM software. Thank you.